the overview of FRC robots, you know, because you need to know that. Alright, so FRC robots. At each season, you need to read the rules. That is 150 pages of rules you have to read. We're going to read a little bit of 2023's maximum starting size, the size of your robot can be, the maximum weight, expansion limit, so how far the robot can expand out of its area once the match starts, specifications, and safety rules, which we're very good at. Safety. Alright, so we're gonna read the rules a little bit. We're only gonna read rules 101, 102, 103, 104, 105, which are actually fairly short. Alright, who wants to read R101? I'm gonna make you guys read. Brittany's read it.
Me?
Yeah, 101.
Frame perimeter must be fixed. The robot, including bumpers, excluding bumpers, must have a frame perimeter containing within the bumper zone and establishing while in the robot's starting configuration. That is comprised of fixed, non-articulated structural elements of the robot. Minor
protrusions.
No greater than a quarter inch, such as bolt heads,
fastener ends,
weld beads, and rivets are not considered a part of the frame perimeter.
So, Rule 101 just basically states that your robot, while in the starting configuration, which is without bumpers, must have a frame perimeter, which will go over the size, and but basically all they're saying is they will give you wiggle room for anything that's a tiny bit out, like bolts, fastener ends, or anything like that. Only a little bit of wiggle room though.
Now, just for you to know, prior to your competition, there's a dedicated job to check the size of
robot inspection. Robot inspection happens at the competition. Yeah. So I believe your practice match, you don't have to get inspected, but as soon as you hit qualifying, then you have to get inspected. Alright, someone read R102, Sophie.
Okay. Starting configuration, no overhead. In the starting configuration, the physical configuration in which the robot starts a match, no part of the robot shall extend outside the vertical projection of the frame perimeter, with the exception of bumpers and minor protrusions such as bolt heads, fastener ends, rivets, cable ties, etc.
So same thing. It's defining what the starting configuration looks like. So the robot must be like this at the start of the match or during robot inspection. Tate, R103.
Robot weight limit. The robot weight must not exceed 125.5 pounds, which is 56 kilograms. When determining weight, the basic robot structure and all elements of all additional mechanisms that might be used in a single configuration of the robot shall be weighed together. For purposes of determining compliance with the weight limitations, the following items are excluded: robot bumpers, robot battery, and its associated half of Anderson cable quick connect disconnect.
You don't have it.
Okay. And tags used for location detection systems if provided by the event.
So this is just stating when they weigh your thing, they will weigh your robot bumpers, battery, and the battery separately, but everything in total must not exceed 125 pounds.
Sorry, I missed that part. Like, does battery weight include?
Yes.
So it's part of the 125?
Yes. Everything must be
Bumper?
part of 125.
Okay.
It's an excluded
No, excluding when they measure. No, they write it very weird, but based off what I understand, they measure the bumper.
Hold up again. Let me read it. It's not. I don't trust it. But the determine the following items are excluded from robot bumper, robot battery, and so they're
They
What do you guys think?
they weigh your robot bumper separately. I know that for sure. It's
The
during
robot weight
it's
must
only
not-
during your weight compliance. But but it says the weight the basic robot structure and all elements including additional mechanisms that might be used in a single configuration of the robot, not starting configuration, just your normal configuration. If it was starting
I
configuration,
still
then
have a
it's-
doubt. Can we ask Discord? It's not. I don't believe
you can ask. No.
I'm not.
I know. Okay, someone read R104.
Okay,
Alan.
read 104.
R104.
A robot starting configuration may not have a frame perimeter greater than 120 inches and may not be more than 4 feet.
So 120 inches basically means they will put a string around your robot, and that string is 120 inches. They will wrap it fully around and make sure that it's in the 120 inches. So basically, the max size is 30 inch per side for the perimeter.
If you consider square, right?
And
Height is 4 feet.
4 feet. This tallish.
No, 4. Yeah, you're what?
Oh my.
Yeah.
Stand up. That's
How are you?
That's around 4.
I'm 5'2".
So we're at our shoulders.
All right. So
I'm 160 centimeters. Okay.
Alright.
Not that long. Okay, I don't think. You're short.
105.
Someone read 105.
I'll read 105. A robot may not extend more than 12 inch beyond the frame parameter. What does it mean?
So, this changes year to year. So, for instance, last year's, this was a lot bigger because they were using robotic arms. But this year's, it's just basically stating when the match starts. So, when the match starts, everything has to be in the robot frame perimeter. But after match starts, your mechanisms can go out of with 12 inch to spare.
So, for example, I have a robot arm.
Robot arm that's last year's configuration. This is this year's.
I know.
Last year's would be a lot bigger because the robotic arm could extend over.
Okay, so if I use a robotic arm for this year, that means
You
the
cannot
arm
exceed-
cannot go over
Or
12
over
inches
12 inches,
up
yes.
of the parameter. Okay, so but it varies each year from year. Okay,
Yeah, that's it for this. Okay, so.
that's a good example. I mean, people are supposed to read all the rules. I know that's
Yeah, you
not
need to
like
read
that.
154 pages of rules. Alright, okay. So, now we're gonna talk about motors. Well, as you know, we chose Kraken X60s and not Falcon 500s. Some pros for the Kraken 500 is higher torque, more robust because the build quality is better, more customizability, and it handles heat better, so thermal. Regarding the Falcon 500, the pros are it's compact, easy integration, and it's less weight than the Kraken. Cons, heavier, complexity. Cons for this is not as much torque, not very good at heat and it's not as robust as the Kraken. So yeah, it's all you need to know. Mostly we chose it because for the higher torque, so that's why we chose the Kraken. More efficient, less power, better acceleration, smoother control than the Falcon. Okay, electronics. So as you can see here for our thing, we use a different type of board. This is what we call a PDH. This one's called a PDP, Power Distribution Panel. And basically, this really depends on the vendors you buy from. For instance, we buy most of our stuff off WCP, Rev, and then we're using SDS, Swerve Drive Specialty Swerve Drives. So, but if you're buying from CTR directly, then you would go normally with the panel here. But also, people say it's not as good as the PDH, so that's also one of the reasons. So yeah, here we have the power distribution board. I'll go over the electronics. So, power distribution board, the PDH. Here is the hub. Now this is connected to the battery via a breaker, so this is how you turn it on and off your robot when the battery is connected. Then, to power the robo reel, it's just a cable connected to the robo reel sending power. You have your breaker fuses, and then your motors connect directly to the PDH, and especially since you're using Kraken, you don't have to do another motor controller like the Neo Vortex or CIM. Radio is powered by the PDH as well using a radio power module, which is this, and then that connects to the radio, which we're using the new one.
In the meantime, if you guys have any question, I think you can pause Ryan and ask a question, right? At the end of the day, I hope everybody.
Okay, now we're going to go into pneumatics. So, here is just a regular cylinder, as you can see when air comes in and goes out. Now this is powered by a compressor, so you need a compressor to activate the pneumatics. Now normally FRC, as you can see here, the compressor is attached to the cylinder, and it's very useful for hanging or climbing anything. So when you need a lot of strength, you normally use pneumatics because it's a lot stronger and a lot better. So for this year's, when they needed to hang from the actual structure, well, you can use motors, which is use a chain drive, but most teams use the pneumatic system. And then you have mechanisms. So what are mechanisms? Mechanisms are subsystems, which is also what we use in coding, built from components designed to perform specific functions or tasks on a robot. Purpose is to interact with game elements to achieve specific objectives in a competition. So that is what a mechanism is, and now we will go over the types of mechanisms that are very commonly used. Before that, we will watch a quick video on the drivetrain, and then I will explain it.
The chassis is often the first things teams design in the beginning of their build season. However, today we're going to be going over a specific kind of chassis design, which we call the modular encapsulation chassis for the first robotics competition. This chassis is unique because it serves as a simple design solution that would meet most drivetrain needs in most seasons. Its easily adaptable design strategy can be implemented simplistically into most FRC games. This can greatly speed up initial season prototyping and serve as an elegant solution to electrical and control system organization. Now, let's talk about what actually goes into this chassis. We have at the center the main structural component, our motion component, various 3D printed parts, our electrical components including the power distribution hub, a battery, our robo wheel, and more, as well as a top and bottom plate. This is actually the namesake for the chassis as it emulates encapsulation. We'll talk about that later. Let's talk about that structural component first. Obviously, within the game, it's subject to change to fit the needs of the game or the goals of the team. Now, the overall perimeter of the structure doesn't have to be rectangular. Various inlets can be shortened, widened, you can add another, or even remove it altogether. The possibilities are endless. Feel free to be creative with the shape of your chassis, but make sure to keep it practical too. There's really no limitation in the kind of drive system you can use as well. Here's a special kind of Swerve drive that's mounted within pieces of tubing, as well as tank drive and mechanism drive, as well as various other drives used within the first robotics competition. Extrusion is one of the most common structural elements used on your robot. Here is an example of a rectangular profile, but they can also come in round profiles and other special kinds of profiles. But not every piece of extrusion is built the same. If you compare the tubings on the right and the left one includes a standard rectangular profile, while the right one includes corner bracing that reduces shear. Some vendors even do pre-drilled holes along the faces of the tube. The reason why extrusion is so common within the first robotics competition is because extrusions can be sourced very easily from vendors, usually at cheap prices. They can also be manipulated using basic shop materials, which makes it a go-to for rookie teams and even veteran teams as well. The only downside is that when you're limited to specific profiles and lengths, it can very much hinder creative freedom when it comes to various design choices you have to make within the robot. Some teams teams have to make sacrifices every year because of this limitation. This leads us to the next method, which is sheet metal. The premise is really simple. Imagine you take a flat piece of sheet metal and you draw some imaginary lines and you bend the metal along those lines. Let's apply this to something a little bit more practical. Say we take a long piece of sheet metal and then we draw two lines along the long edge. When we bend those inwards, you can kind of see it makes the letter C go backwards. But if you put two of those together, you can kind of see how it mimics that same rectangular profile used within our extrusion. Put those together, and you can actually create 90-degree angles using sheet metal tabs and bolting them together using fasteners, or welding. Repeat this process, and you have what looks like a chassis. Here's another example. Because sheet metal comes in flat stock, you can use CNC machinery to actually cut out custom profiles on said piece of sheet metal. You can then bend that after the fact and create your very own custom part. Now, there are some pros and cons to using sheet metal on your robot. The obvious pro is that it allows you to create much more complex geometries, which allows you to solve design problems in a much more creative manner. The easy implementation of CNC allows you to create holes for either fastening or lightning much easier. Now, teams don't always have the resources to create sheet metal parts. This can be hardware, whereas they don't have a CNC roll break and shear, or a CNC router which allows them to cut through metal parts. It's also a completely different CAD workflow to learn, which is a whole other obstacle when it comes to creating complex geometry. Your robot functionality is realized through your electrical system, which is characterized by standard crucial FRC parts. Of these crucial parts, one of the most important is your power distribution hub. You'll see a positive and negative port, as well as various other ports for different kinds of fuses, for different amp needs. For lower voltage applications, such as 5 volts, you will sometimes need to use a voltage regulator module to power these parts. And of course, the source of all of your power is standard 12-volt FRC battery. These should leave room for a circuit breaker in an easy-to-reach, visible position. All of the power runs directly from the battery to the circuit breaker into the power distribution hub. When it comes to robot control, the most important piece is your robo reel. This is the brain of your robot, where all of your code is stored and where the robot is ultimately controlled from. Driver and robot interactions happen through the radio, a standard piece of FRC hardware. The radio module requires both an Ethernet and a power cord. Because power cord are currently being pulled, an external module can be added to pull power from an Ethernet cord rather than a power cord. The benefit of this is that an Ethernet cord is kept in the port during a mechanical latch. This way, it can't be pulled during the latch. When using pneumatic components on your robot, be sure to include a pneumatic hub which controls the solenoids on your robot. Some teams choose to put a compressor under their robot as well to keep a standard 60 psi within all their pneumatic networks. Don't forget all the different kinds of sensors that you can also put onto your robot. Just to name a few, there are some visual sensors, such as a camera, distance sensors, such as LiDAR, and gyroscopes, such as the one seen on the right. Camera sensors are especially useful, due to the fact that they can be used for vision detection. However, this is a pretty taxing process from a memory point of view. So, you're actually able to include code processors onto your robot that can aid with processing as to not overload the robo reel. Special sensors can be purchased with the code processor included within. That way, separate code processor component isn't needed on the robot. 3D printing is one of the most versatile technologies FRC teams have at their disposal. With chassis design, here are a couple of very important parts that you should consider printing. One is a swerve guard. When using swerve modules mounted at the corners of your chassis, it's entirely possible that cables can get caught up in the swerve treads. But by 3D printing these 2-inch tall swerve guards, they can mount within the 2 inches of chassis. And don't forget battery cleats. The battery cleats are designed to fit specifically within the upper voids of your battery. This keeps the battery from moving around within the robot, especially if it's laying straight down. Up to this point, I've been explaining a pretty standard FRC chassis. None of this information is new or revolutionary. However, the one thing that separates a modular encapsulation chassis from a standard chassis is the word encapsulation. First, let's go over how to actually organize the electrical components onto an example chassis. First, we have to mark the corners of where our Swerve drive modules are going, and feel free to do the same for tank drive or nitrogen drive or various other drive systems. Next, map out your other major electrical components that take up more space and weigh much more, such as the power distribution hub and the battery, possibly one of the heaviest components on your robot. Next, group your control systems together, such as your robo relay and your radio, seeing as they're connected through the Ethernet port. If applicable, be sure to group your pneumatic pieces together as well. Also be sure to include sensors, such as a gyroscope, which typically work best when placed in the center of the robot. When you place the bottom plate on this chassis, you can kind of see how it all comes together. Yet one of the strengths of the chassis is having accessible components at all times, where there is maintenance and improvement. So, say you had some kind of superstructure on top of your chassis, you then eliminate the ability for you to work on the specific components, and placing your component on top of that superstructure then defeats the purpose of a centrally organized control system. So, we offer a different solution, mounting your components upside down. That way, the top accessible portion is actually on the bottom of your chassis. Your bottom plate then becomes a top plate where the components actually mount to. This actually provides square support, acting as a gusset for your entire chassis. You can then add an actual bottom plate when cutting out accessible lightning holes as well as other mounting holes. Feel free to follow this strategy. Mark out the location of your larger components. We can remove a lot of geometry this way. Next, mark out the location of your battery. This is where you might need to access it. Next, mark out any diagonal support you'll need to maintain on your plate. This is a portion of the plate you want to keep for structural purposes. Your final part should look something like this. We can repeat this methodology for the top plate, and be sure to account for components that are taller than 2 inches, or whatever the thickness of your chassis is, such as your compressor or your battery. Now, you might be wondering, how do we attach the superstructure to this chassis? Say at this point, or at this point. Using this example, we have 4 possible mounting points. If we submit on this corner, we can actually add a gusset plate and mount it using fasteners to secure it to the main chassis. You can also use L brackets to mount pieces at 90 degrees or any other angle provided by specific kinds of brackets. But what if we wanted a superstructure that actuated from the chassis, such as this pivoting arm? The gussets can look a little something like this. See how it captures the arms on both sides of the chassis? You can then use fasteners to secure it to the actual chassis tuner by putting the fastener directly through the piece of tuner, or capturing it from above or below. Here's another real-life example. The circular parts of these gussets are actually hinging points, and you can see the various fastener holes located on there as well. With this example, we actually wanted multiple rotating axles around the same location. This proves that we can actually mix multiple functions into one plate. Now, you're probably wondering, what about motor controllers, or solenoids, or other pieces that directly control a robot? These components are unique simply due to the fact that they take up much more space on the robot. There are plenty of creative ways that you can mount these. Here are 2 simple examples. We can, say, construct walls out of aluminum tubing, and using polycarbonate plates, you can attach your motor controllers and your solenoids to the polycarbonate plates. With a more low-profile solution, you can attach your components to polycarbonate plates and attach them back to your chassis using stand-offs. We're excited to see what kind of creative solutions you can come up with using the modular encapsulation chassis. From Team 4611, ongoing effort.
Right, keep on that video. I think this is one of the best videos overall. Introduce every single part. As a matter of fact, I want each one of you to ask a question. You think about this video, prepare. I have a lot of questions, but this video answered a lot of my previous question too, like especially the modular design. You come all the way around from FRC. When we design a robot, we try to make it modular, easy to attach, the same as those metal parts. I was wondering, let's see, even if we get the base ready by summer, right? When the real competition comes, you need to design the attachment part. How do you put it on? Like that gave a lot of good examples. So, Bernice, you're gonna be the first one. Think about any question that you have from this video. Ask. Ask Ryan.
You know, for the metal sheet, like do we have the equipment to do that, or like take
The metal sheet.
Yeah.
Do we have equipment to do that?
No.
Okay, there we go. Question.
Now that's actually a good one because in there, I'm not sure you know if you notice there are 3 proposed methods, right? The first, can you go back? Yeah, just by the standard extrusion.
To use it, or
No, to make the frame.
Oh.
To make the frame, the first one. Anyone remember what's the first one?
Use.
What's the name of the first one? Very simple, straightforward. They call it extrusion,
Oh.
right? As a matter of fact, we just place an order of that. Yes, the one on the left, right? You should know as a matter. The FRC recommended website Studica, they sell this piece for $108 for every 6 foot slot. Right? 6 foot slot, $108. Now we look at around, we asked Uncle Ryan, and he recommended another website. How much it cost?
$50.
$50, right? It's a half price. I mean, yeah, $50 is not a big deal, but if you try to get a lot, let's save a lot of money, right? It's here and there pieces. Now, Ryan, I got a question there. On the right hand side, he added some. Later on, there's like a enhancement, right?
You buy that.
Huh?
You buy that.
You buy the whole piece, or you buy something to add on to it?
No, you buy the whole piece.
All right. What's your decision not to get those? Is that
Too expensive.
Too expensive?
Yeah.
But would that be stronger?
Barely. A lot of teams don't use it. It's too expensive. It's like $300 a pop.
A bar. Okay.
Because it isn't just cutting. They have to cut it very precisely, and then you need a really special, like, expensive type of cutting machine.
Okay. For now, I think we're gonna go with that. If we are lucky enough to get a big sponsor money, then we may try that. But this is good enough. Most team unit is. The other one is what Bernice said is a metal sheeting. Now, apart from the George Brown, we have a very big department, tool and die, and I know my colleague there, they do metal sheeting very well. Each year, George Brown student will win the national gold award. Anyway, so I could go there if necessary, but we're not going to do that because it's a little bit complex, right? So one thing I saw from here, Ryan, is you could first CNC cut it, then you bend it, right?
Yeah.
So you can design any kind of profile shapes you want.
Yeah.
So that's another option. Okay.
All you really need is just a top sheet and a bottom sheet. That's all we're using.
Okay.
We don't need to design our custom, because that's designing the whole, like, extrusion tube.
Yeah, I'm not sure that's some kind of fancy attachment where you attach your
No
stuff.
team does that really, except probably like 10 teams in Canada.
There's metal sheeting?
Yeah, they have their own CNC machines, so
Oh wow.
Wait, what's it called?
you don't need to look for it.
What's the machine called?
You don't need to look for it.
CNC machine. We'll show you later. All right, Sophie, do you have any question?
Right now, not really.
Nothing. You're satisfied with all the content that answer all your questions?
Damn,
I guess.
he got you there.
Okay, let me ask you why. No, I'm not there. Okay. Ryan probably already answered the question. Right now we're using, what's the system name we're using in terms of power?
Power.
The power distribution.
PH? Or is it that one? I think?
Yeah, what's board?
What the board? Like
What's the name
where
of
it's
the board?
from?
No, power
Isn't it the PDH?
Yeah.
power distribution board or
Hub.
hub. What's the other option?
PDP.
Yeah.
Power distribution panel.
Yeah, so he already answered why we go with this, not the other one.
Well, apparently it's better.
In terms of, I didn't catch, I didn't know. I
More
asked a few
ports.
times.
There's more ports. It's lever controlled, so it's not. There's no copper wire sticking out. Because with the PDP, it's screw in and pull. If you pull it, it could come out really easily. But with this, it's latch. It's a mechanical latch. Also, it's because of the vendors. When you buy everything from Rev, you normally go with this one. If you buy stuff from CTR, then you go with that one. But since we're using WCP stuff, WCP and Rev go together.
Okay. Yeah, a couple of reasons. First is systematic integration, right? There are two different approach. Since we're using WSP, we're going with that. All right, Tate, question.
Are we gonna do like the 3D printing thing, like the Swerve drive protector or something?
So why you use 3D print?
The Swerve drive protector. I don't know because
Swerve guard.
Yeah. So your question is why do we use 3D print for that?
No, he's asking if you're gonna do that.
Yeah, we are.
Yeah,
We're
we
gonna-
are.
we're
We
gonna-
are.
We're gonna do swerve covers, not swerve guards. Swerve covers are better than swerve guards. So we're gonna 3D print our own swerve cover here.
Holy.
money.
They
3D
sell for
printers.
$200.
Yeah, you can make a profit. If we print this, we could sell it and make a profit.
Do they have online design?
Yeah, everybody 3D prints and no one buys.
I know. Do they have a design? We can. We have the design.
No, they give everybody has design. It's the same design. SDS actually made it. The actual company that sells the swerve guard made the 3D model for us.
So we can put our logos on it.
Yeah.
Yes.
Good. All right. Anna, question. Regarding this video, any question you have?
Coffee table recall.
Okay. But next time, next video, if there's any, I want you to be the first one to ask. All right.
Let's move on now.
Yeah, but this is a very good guidance for us. Ryan can pull back towards the end where you attach the stuff onto the robot, right? If you do, I'm not sure. Yeah. So you understand how the way he put it. He put a traditional bottom plate as top plate as bottom plate. So the hub you send it upside down, right?
Yeah.
Yeah.
Now the only tricky part, if you look at the picture, I mean, the battery you can easily remove because it will be exposed. If there's any wire loose, hopefully not, but
You're siliconing everything.
yeah. So you have to, you open from the bottom, open down the third.
It's already open on the one.
I saw the bottom. You have a bottom plate, right?
Which bottom?
It's covered.
The-
You gotta cover the bottom, like with a whole sheet metal, because otherwise, this is your top plate.
No.
Otherwise, you are exposed. Anything that wrap in, you're gonna get
you
jammed,
see how,
right?
like, the
What
two-
do you mean
Yeah.
get jammed?
Don't you see how there's also holes in the bottom plate? And the
He
top
says
plate?
cut it.
Look,
This,
Cut it out like this.
your final
this is
lecture,
top plate
something
or
like
bottom plate.
Huh?
This is the bottom plate.
This is the bottom plate.
Top and bottom plate are the same thing. They actually, that's what it's called.
That really worries me, like, so with
Something
the,
to worry about for this one.
seriously?
Yeah.
Seriously, first off, if this is a bottom,
Yeah.
there's a huge risk if there's a, for example, dirt or pieces from the carpet may get into the panel, right? I would assume you have something to cover the panels.
Yeah, probably, but not a whole sheet of metal.
Not whole sheet of metal, but I guess it shouldn't be fully exposed. Am I right? Am I wrong?
Most teams do it like this.
But also, it's like it's not like brushing the
If you
ground.
watch at FRC, most teams do it like this, so they have easy access.
From what I saw, most of the team, the board is facing up.
What do you mean board? Yeah, most teams' boards are facing up. We're facing our board up. I don't want to face it down. But if you see the teams that face it down, they have an exposed back.
Yeah, facing down has a benefit that you have a flat.
But you have more risk.
Yeah, that's what I'm saying. Unless you have some protection mechanism.
For this year, we're going to go up because we're better like that. And I'm not trying to risk $400 worth of stuff.
Unless you can build a second layer to cover it. Anyway, okay. So
So
that's
that
actually
gets
my
rid
point.
of the points. Because the point is for easy access.
Yeah.
That's why they do this.
Guys, what I'm showing you is, you see, when I watch video and you watch video, I don't want you to watch video as a movie, right? Where is it? Oh, yeah, okay, who cares? Whenever I watch this, think, right? Critical thinking, that's because this is your project. If at any point, engineering speaking, potentially fail, it will fail, right? So there are no bad questions, just keep on thinking, Okay, good, next.
Okay, bumpers. Alright, so your bumpers, the rules state that you must have your team number and you must have the alliance color. So some teams do this. Some teams make 2 bumpers, which they make easy to put on and off. Or you have a like one of those like Velcro strips that you pull down and it changes color. So, but genuinely speaking, you want to have 2 bumpers just in case.
So Ryan, pause here for a second. I was a judge for the Georgia region, right? During the judging session, there's an award called Innovation Award. Usually you think the Innovation Award will be how the robot is designed, how creative, how newly some new system, right? And when the judge proposed more than one judge proposed one particular team, because that team using the macro to change the bumper very quick. Where are those judges from? Those judges from Honda. And they said from a manufacturer point of view, anything that saves time will save money. So from that point, they proposed the team not work on the robot, but working on a macro bumper to win the war. Of course, eventually we all argue, we remove that idea. But the Honda engineers stand strongly. This is really innovation because
it is a business standpoint. So
yeah.
But is it innovative though?
well, you're looking at it as a business standpoint. You're basically running a business when it comes to FRC. So I don't blame them. Simple bumper.
I'm sorry. That comes to the point. You know what? So far, it's really only 2 ideas. Can we come up with even something interesting and new
Guys,
idea?
to put a TV on the bumper, we just project 2 colors.
Yeah, I'm thinking digital stuff, right?
Wow.
Just like the Chinese billion.
Oh my.
Hey, why don't we do that?
Or LEDs.
LED, yeah. Chinese billion.
If you smack each other enough,
Yeah. Hey, seriously, look into that. All right?
You mean like those crazy little shows?
What do we have?
Yeah, show. We call it high-low.
Finger changes
Why do you
color.
have a layer of LEDs than glass in front of it?
I'm not sure they allow that, but hey,
No,
high-low.
your bumper must be with a fabric coating, then pool noodles, and then a plywood. You must do this.
Yeah,
If
they
you
gotta
don't do
do
this, they will disqualify you.
Maybe we can spend 2 months investigating. They gotta be.
Basically, your fabric.
like that?
Yeah, your pool noodles are here. The fabric wraps around, and then the plywood is that the part that goes.
Interestingly, I still don't understand the diagram. The left side, that's a plywood, right?
Left side, yes, plywood.
What is the two
Those
blue
Pool
side?
noodles.
Wait, is that
What's the pool noodle?
What?
Protection.
Yeah.
Oh, the foam.
Thing, yeah.
The foam thingy.
God.
I don't play with those. You okay?
When you used to swim, you have to have pool noodles. You cannot do any alternatives. They will disqualify you.
Hey, that doesn't say I cannot put a rotation rod in the pool noodle.
No, you can't. You
Why
can't.
would you want to do
You
that?
can't do that.
Well, I rotate, I change my skin, just how the way Haidilao show works.
Lucky.
No,
Hey,
you're only allowed to use
Hey,
Velcro.
just a way of thinking, alright?
Or technically you could have Velcro on top and bottom and then just slap the blue lines on the thingy. Like just cover it, you know? Instead of actually
Hide
You're getting us disqualified.
You try, I'm inspire you to think outside of the box, like literally outside the box.
Oh my.
And you hope this protects the robot from any damages.
Disqualified if you do. It's okay.
Okay, now you have floor.
That's a big ball.
So
What is that?
this
Which
is
year is this?
this is 2013, I think, recycle thingy. Basically, floor intakes are taking, this is very common, so like collect balls from the ground or the nodes from the ground. Or
Why is the
taking.
ball so big?
This was recycle year, like I forgot, 2013,
Isn't there a year
recycle.
we had to throw like milk cartons? Like the human had to throw milk cartons?
Milk cartons.
I have no idea. But basically, it's just taking stuff from the ground and then loading it into your launcher or anything like that. And it's fairly simple. It's just a couple rollers or tires and then connect it to a
And
motor.
then they spin.
And then they spin.
They spin the opposite direction or the same direction?
They would, I mean, it depends. Some, you want to have it like controlled with the remote because what if something gets stuck, right? Then you want to do it the opposite direction.
Oh.
But generally speaking, they all take one direction.
Yes,
Okay.
and then it goes.
Alright, okay, so that's floor intake. Then we will go over launchers. So launchers are also very useful.
Do
Now,
those go the opposite direction?
yes,
Okay.
because when you launch, one goes right and one goes left. So that's, yeah. And generally speaking, you have the floor intake to take in the actual note, and then you load it into the launcher, which then uses just normal tires to launch it far. And that's normally with 2 motors, not 1.
Well,
Although
know
you could
for
have 1.
the- You know, for the crescendo this year,
Yeah.
some teams like do both. Cause like technically, you could like do it one direction. Like
For like launcher and
yeah.
yeah. Okay. So good question.
Elevator.
Elevator.
Okay. So for the crescendo season this year, there was an amp on the side. Well, not the amp. I forgot what it's called, but
thingy?
yeah, the thing. Most teams use just the floor intake because they don't need so much speed. So when the floor intake comes in, picks up the note, they just do this and then they put it inside the box. But then what's useful, you need the launcher for the amp shooting,
Oh.
right? So that's why most teams use launcher along with the floor intake. So it picks up, stores it, and then launches it into the amp. So yeah, regular tires, both 2 motors. You could have 1 motor run with a belt, but it's highly not recommended because when that motor fails, your whole thing fails. I mean, if 1 motor fails, you could still technically launch something. So yeah. And then elevator. So this was used in the 2022 to 2023 season, and basically you had to pick up these boxes and cones and place them on here. And elevators were very important because you these notes. Actually, no, this isn't a very good example, but they were placed high up, so the elevator could raise it, and some need to be placed lower, so up and down it could reach all of it. and place the nodes for the cube and cone onto the actual structure. So
And it seems to me the elevator is a little bit overkill for this, but I guess most of the team, the accumulated knowledge of the elevator is very common.
reliable, a lot more reliable than robotic arms.
You know what? I hope that argument. I mean, I think if you look at here, I had a discussion. How come no? Very few FRC team use robot arms.
Because it's not reliable.
I doubt it.
There's nothing to argue about. It's facts.
Hey,
not opinions.
I don't like it. First off, I don't like that. There's nothing to argue about. Anything is questionable. Otherwise, how do you get innovation
Can
ideas?
energy be created?
Well, that's a fact. So far, you know what? You could knock it down. You know, if you have enough evidence, you could knock it down. That's a solid. Hey, the Earth was flat
Oh my
a
god.
few hundred years ago, and people get burned and killed.
I'm saying that, like, maybe there's a reason why not many teams use it.
Well,
maybe
because
you could argue that maybe you're special and you're good at engineering and you could make your robotic arm more reliable than an elevator.
Yeah,
But
okay.
for most teams, they choose the elevator over the robotic arm because it's more reliable for them. That's
For them.
statistics, that's data. I don't know why you're trying to argue about that. You could argue that maybe for
okay,
you it is.
you know, 2 years ago there's no AI. Who would think of AI? It's only existing in the sci-fi movies or books, right? Now we're using it on a daily basis.
What does this have anything to do with AI?
No, I just use an
This is
example.
mechanical
You have to
stuff.
think about
AI
it.
is
You use
software.
knowledge.
This is
and
hardware.
you know the robot arm is very popular now, and we are making robot arm. And
Robot
potentially
arms
we might
existed
be
10
using
years
robot
ago.
arm for one of the time missions, maybe even this
No,
year.
you could.
Robot arms existed 10 years ago, 20 years
Yeah,
ago.
because of the reliability and the torque.
Or maybe the
You're
robot
handing me a
arm
knife right
extends-
here.
Sorry.
It's
or
not as
maybe
good
the
as it
robot
can be
arm
right now.
extends more than
Elevators have been here for 40 years, 40 plus years. They've been more improved than a robotic arm.
Elevator
20
is
years
kind of
more
bulky
improved. 20 years down the road, then you tell me robot arm is.
Oh,
Or
by the way,
maybe-
I want to ask a question. So that going back, you said 125 pounds, right? Does it vary each year? Because when I look at this, the elevator will be more heavier than the long term. Isn't that?
The rules always vary each year, but normally the weight stays the same.
Okay.
I'm sure it's
Interesting.
elevator because maybe the
So
robot
it is
arm
normally
is like.
120.
The elevator is heavier
I'm
than
pretty sure the robot arm will
No,
extend.
robot arm is heavier than the elevator.
No, the long term thing this year. The long term. you know.
Launches aren't that heavy.
Launchers are not heavy.
I know. So you get my point. If the weight is the same throughout the years, only 125 pounds, the elevator itself, the tandem itself, it take a big chunk of the weight, right?
Yes.
Yeah. So that's my
Or
thing.
maybe like the elevator, like you know how robot arms need to extend? Maybe extends more than like the like.
No, I think it extends more stable.
Also, it depends year to year. So in this case, elevator would be a much better because you're doing the same action. Robot arm is used for doing different actions.
Yeah, robot arm, you have a very.
If you're doing the same action, what is more reliable? Robot arm that has to go.
You could do that, yeah.
Or
They just haven't gone through rigorous FL training with the development of robots
This
and
isn't FL.
using industrial simulation software with the knowledge of an advanced whatever I cannot make up anymore. And by the way, the weight, the additional weight can be added onto the bottom to support the center of weight.
You can't use robotic arm. Robot arm is basically just an elevator. It is only 2 axes, so just the same movement doing this. Now Spartan actually tried a 4-axis robotic arm. You can you read the report on it. It's not very good.
Yeah.
Even they claim it's not good.
Wow.
Read the report.
But I love their design. But look at it. This is an innovative design,
Is it efficient?
and they're thinking outside the box because nobody has
One reason why it's bad is look how small the robot base is.
Well, why didn't? So is that the reason?
Due to no.
They didn't have large enough support, basically.
Because if they made it bigger, then the whole thing would be too slow with the robotic arm.
Why the robot arm take less?
No, it's
weight?
it's lots.
What material they were using? Carbon fiber? Or
Yeah, carbon fiber. Robot arm is heavier than elevator. One hit, boom, your whole thing's done.
Oh,
Well, they could use the arm to push themselves up.
Yeah, that's what they did too. But
But I just love.
they're the only team that's ever used the 4-axis robotic arm.
Well, hey, put this way.
Two-axis robotic arms are very common.
You know what? The first generation may not be good, but that shouldn't stop people because Elon Musk busted so many rockets. If he stopped right there, there will be no nowadays SpaceX. And going back to our FR, I still hold that argument. You look at your FR robot. So many people, 99% of the team, using a 6 or 7 times. We use a single robot and integrate everything.
We can do it.
No.
20K. You have the money. Give it to me. I'll do it for you.
What I'm saying.
No. There's nothing to say.
Even if it fails, doesn't mean the concept is not
Hand me the money, I'll do it.
We designed a robot so complex, even the judge has no idea what we're doing. And even though the performance may not be there, but it meets the industry standard.
We're not Elon Musk
system and clear out of most of the missions. And I just feel like so many other attachments put on the robots and even if they get off the school.
I agree. We're not Elon Musk rich.
This is very
Are we?
are you Elon Musk?
Are we Elon Musk rich?
Let's think about it this way. How about the first year, we get it working.
I know.
And then
I
the
agree.
second
Yeah,
year,
do the
we
bare
get it
minimum.
working.
No. It's flashing the camera.
I know.
I
I tested it before.
Oh.
Alright.
No. I completely agree. You want to do it this year?
No, I'm not saying it's just a conversation, discussion.
No, but if you want to do it, we can do it. I want to do a team, but we need the money to do it. Hand me 20K first.
I'm not being I'm just saying.
Hand me 20K. We
Hey,
can
I'm
happen.
talking about concept, I'm not talking about actual execution. Yeah.
Why talk about concept if not executed?
Well, if you don't dream big, then you will never get there.
Yeah, we already dreamed it. Now we have to execute it.
Yes,
That's
I like
about
that.
execution.
No, we're looking at all this problem and figure out what's the potential issues. Alright,
Hand me
so
20K, I'll do it. Hey,
Alright.
hand me 20K right
I like
now.
the conversation. Very good conversation. Continue.
And then you have the climber. The climber. Some of them use pneumatics like this. This actually you could buy off any mark, which a lot of teams use. And some of them are belt driven, which is motor. So, relatively speaking, you want to use pneumatics because they're better.
Stop.
They're
jamming
better.
your pen into the wall.
Why? You
Why
want,
not?
you want 20K?
Use the laser.
Yeah.
Hydraulics.
I'm gonna post it.
Why pneumatics, not hydraulics?
Huh?
What the hell would you
Why
want to use
pneumatics,
hydraulics?
not hydraulics?
Huh?
Why
Can you
pneumatics,
compress
not
air like more than like fluids?
Why hydraulics but not why pneumatics not hydraulic? That's his question.
Why can't we use
They don't sell hydraulics. Everybody wants to use it. They don't sell it. It's not legal in FRC.
Down.
Oh,
It
stop.
was proven too powerful. before.
Really? Was it too good?
Yeah, it was too powerful.
You know, Boston dog and they
It almost killed someone.
Really? Almost what?
Because the sudden pneumatics are like gentle air compressed, right? But the sudden force of hydraulics is really.
You saw Boston Dynamics, the dog fall apart and the liquid split all over the place. They were using hydraulics.
Yeah, hydraulics are too dangerous for her. FRC, normally, when you run RC cars or anything like that, you would use a LiPo 4 battery, which is lithium battery, which is used in Tesla cars. But they just have to make you use the standard 12 volt because they say it's too dangerous. I
You
completely
know,
disagree.
The hydraulic thing is
LiPo
one
batteries
break
are so
away.
much better.
The hydraulic,
Proven too.
hydraulic thing is one break away from the.
There's a whole argument with FRC on the forums. Yeah.
Do they test for it?
That's what.
Well,
They
to
test
me,
the
that's
batteries.
because they don't want a full Tesla
Like,
battery
the
in your
different types.
120-inch diameter robot.
No, this is the only type of battery you're allowed to buy.
Diameter. Not
So
diameter.
his question should people actually test it?
What if you took like a light bulb battery and slapped it and like made it look like
Is it?
the other type?
Okay, but why would
No
you
one's
want
stopping you
Tesla
from doing
battery?
that.
What do you want?
But do they test it?
What do you mean?
Yes, well.
No, they don't test your batteries. No one's stopping you from doing that. You could make it the exact same way. You could cover with this, so you could use LiPo. But most of these electronics would die. LiPo is too powerful.
Yeah, why would you want a full Tesla battery?
Yeah, that LiPo 4, lithium batteries. They're expensive too.
Yeah.
If you read FRC rules, if your individual parts, so for instance, if this battery was $601, this is illegal. This is called an illegal part. Everything must be under 600 USD. Each part. So the motors must be one motor must be under 600
Isn't the
USD.
Limelight also banned?
Limelight is not banned. It is banned in FTC.
Oh, okay.
Proven too dangerous in FTC for FRC. They used it 1 year, because it uses reflective tape.
Oh.
So
Does someone get blind?
no accidents. Just it's too powerful and it's
And
not
the
no use.
hydraulics are too OP for.
Yeah, hydraulics are too OP for FRC. Okay, now Swerve drive. So here I have 2 Swerve drives. Thanks to Bernice, she built this, and Ricky, which I have
Remember
already.
how you built it? Yes.
So she built the first official one. Now the reason that I say she built the first official one is because I forgot to put a piece in mine, so it doesn't count. So she built the first one. I have 2 more in the shelves, which I will get the breakers and have them running, but I will demonstrate to you the. So just to quickly go over, what else we need in each Swerve drive is a CAN coder. Now CAN coders are 100 USD, so total we need 4 CAN coders. Now what the CAN coders do
Only
is
$400. I don't do much.
400 USD,
Yeah.
and then you need a pigeon and stuff. So
Same thing.
the CAN coder goes in, uses a magnet, which is an encoder, and it detects how much the wheel spins. Now, you might say Krakens already have a built-in encoder. Well, the Krakens don't know their calibrating position, so every time you want to do that, you have to manually hand calibrate it. But for CAN coders, they remember each location, so then say it's here, and when you turn on the robot, it will automatically spin back to the middle. Unlike Krakens, this would be their 0. So wherever you turn it off or stop the robot, that's the 0 position. So CAN coders are definitely needed in order to do FRC stuff. And you will also need something called a pigeon, which I'll go into. But basically, Swerve drive, diagrams as you can see here, all of them facing forward means forward. All of them facing side means go this way. And then all of them like this means spin.
Yeah, that was so revolutionary.
I know, right?
Amazing.
Okay, now let's talk about our design. This isn't our 3D model, okay? This 3D model, I have a 3D model that I built, but computer too slow to run, so we bought a new computer.
Pause for a second. I have a question. How come everything come from him? As much as I need to get the project moving, this is really need to get it done. But I need the team support, right? And if you have technical issues, assemble, build ideas, you could learn 3D softwares. This is not only good for the team, also good for yourself.
So our 3D model, just to summarize it, once I get a new computer, I'll show you. But basically, instead of these 2 beams, our beams are located down more into the actual chassis here.
Wow.
Just like the video show.
Just like the video show. Okay.
What computer is my computer?
LOQ Levena.
I think my computer might be a bit faster.
Yeah, I know. My computer will be better than yours.
Yes.
Mine
Yeah.
not. Your computer, it's bad.
Wow.
You should.
Working is very good, but you don't have a GPU. You have good CPU.
Stop missing his computer.
I'm sorry, I just hate Apple computers. I absolutely despise them.
MacBooks? Yeah.
No,
The only reason you mentioned that is he just bought a new laptop
Wow.
for this FRC.
Yeah.
Matthew?
No, me.
Oh, wait. Yeah, MacBooks suck. Like, why are they
MacBooks
considered?
My feet had somehow
I just said I agree with you.
It's a gaming work laptop. So it's
for
a
certain
slim
things.
game
For
fan.
certain things.
Specs 4060, i5 13th gen, 16 gigabytes CPU.
No i9. No i9.
So when you build computers, remember this: the I number doesn't matter. It doesn't matter. It's the generation after that. So 13, 12, 500K, HS. Because the i9, if you actually do the i9, but if you have an i9 10th gen, the i5 13th gen is better. So the I in front of it doesn't matter.
What is bro's name?
It's just the core number. That's where the I comes from. Okay. Anyways, our design
Stop
very,
pressing the wrong button.
very. I need to get used to. I don't know how this works. It's just the up and down arrow.
It's a
Okay.
stick.
I have to click down to go over there.
Oh.
So yeah, design better.
Yeah.
Okay, Ryan, sorry, go back a little bit. Question. I know you're gonna buy the extrusion, we're gonna, for the extrusion, like, are we gonna drill the holes? What's the purpose of the holes?
Huh? They just bought pre-cut ones.
No, the holes on the, like,
So
will
that
that
they
increase,
can-
just reduce the weight?
No. They bought pre-cut ones, pre-holes,
So they can
pre-cut holes.
drill the stuff.
Yeah, we bought. No, they sell. It's the same thing. They just bought pre-cut,
Isn't it
so
the
they don't
drill
want. They want to have to drill it. We have to actually manually drill it because we bought the cheap ones.
Okay, yeah, okay.
Student
because
cut
the
ones.
labor is cheap.
Student cut ones are these ones.
Oh, the 108 and this was.
They have pre-cut holes,
What's the purpose of holes?
so you don't have to cut holes.
You can drill the stuff in it.
You don't have to cut holes. That's it. So now I can just directly attach it. Now I have to bring my 6 feet metal pipes on a gold tree to your school, then enter the school with 6 feet metal pipe, metal extrusion tubes, go into your lab, now mill each hole, then bring 6 feet, like, I don't know how much they weigh, like 10 pounds of stuff in my backpack, just metal sticking out onto a gold tree, and then coming back.
So you're the Ninja Turtle. My name is Captain.
So I have to carry three,
Go Ryan,
6
Ryan,
feet.
Ryan.
6 feet.
Walk past
6
school
feet is
and
this tall.
your school's here.
Metal extrusion tubes in my backpack onto a GO train, then a subway.
Okay, we're gonna try.
Then no, take GO train.
What, someone steal your stuff?
No.
6 feet, I'm not gonna take
Line out.
Why?
6 feet, Ryan.
Yeah,
You're cutting
I
it.
feel embarrassed because
You're
it's
cutting
even
it.
higher than me.
In my backpack, that'll be like 7 feet. No, it's fine. We're gonna cut them down to 28 inches.
Yeah, like.
So yeah, our robot's gonna be 28 by 28.
Yeah.
No, I thought you said 27 by 27.
No, I said 28 by 28.
Wow.
No, 27 and 27 by 28 by 28 is a huge difference.
There's a huge difference?
Huge difference.
Okay, wow.
Yeah.
How do you want to
Yippee.
put those
Oh,
holes?
yeah.
Bro, guys,
I'm gonna
we're
cut
full and tall and Bernice did that.
Oh my god. What?
You mean like 187, like 180.
I said
Why don't you just
But he's
4,
gonna
5,
have
4,
183 centimeters.
Who's gonna take up a few seats on?
One. Oh.
No, it's almost
You don't even need to
5
centimeters.
centimeters.
I swear if you compare it to
In,
me.
It's about like 184 to 180.
You don't have
It's
solid.
like plus one.
The SolidWorks is a paid software. He needs to give you your
I like that
Times
kind of
2
humor.
Tate. We're using Tate's now. A figure. He.
Can we see a
used
6
it for
feet
measurement.
tape by the time we finish?
I'm
Yeah.
gonna cut it down to
Can
28
you
inches.
get- Can you grow tall when you're like 18 years old?
Where's the ruler?
So now you'll be a tall guy, not a short kid.
I'm not sure what we're doing.
In your whole life because you're just like short.
Okay, right.
Alright, this will become popular, so let's.
Sorry, Tate.
Somebody just officially apologized for the early comment.
Very tall kid.
This is internal discussion. Oh, you know what? I'll censor that.
Standard height king. So.
Maybe, I don't know.
Censor that part.
I don't know. Censor that.
Censor
Huh?
She's swearing.
Alright.
Well, that's normal.
28 inches. Here's reference. 28 inches is around this. 28 inches.
Not that.
We're gonna cut it down to this.
Zero survival skills.
So what? 3 feet? 3 feet. Okay. Next.
Okay.
Coding.
Wow.
You're not coding, don't worry.
Let me
Actually, no, you might do
No,
coding.
bro, let us code.
let me control.
Let us
the
code,
robot.
Ryan.
I won't.
Alright, are you gonna do a demo?
Yeah.
Okay, people go there, go closer, take a look at it. Be careful.
Before I do that, let me explain the code.
Okay.
It says coding,
Okay.
not demo.
Not that.
Okay, anyways, from code last time, it is a lot easier. All I'm taking is the Xbox controller and that's it. Okay, you can come up now.
Be very careful with the cable, please. I don't go over that way. Matthew, the other way. If you could, stand on the side and help walking.
Can you take this away? Someone is gonna trip.
No.
Take this away.
No.
Take it away. Just put it on your desk.
No.
Just put it on the desk.
I'm holding this. Okay, Alan.
Yo, what's up, guys?
Try to take my shoe one more time.
Probably Ryan. Okay.
So if you want to do the honors,
Sure.
okay, push this button in.
Okay.
This one.
Wow.
So, just to teach you some robot signals, okay? If you see red on this, we're fucked. If you see orange on it, we're good. If you see green, if you see like just it not blinking orange, that means don't go near it, you will die. Alright, if you see it green, that means you are going to die if you are near it. Okay? So that's just some things to keep note. If you see orange and red, that just means PWM is loose. It's easy fix.
Okay. I hope that once you decide that
You're just unlocked my new fear of motors,
I
man.
hope I'm the one to like.
You are.
Forcefully
I
grab
hope
it
that
when
once you
I
touch it, it turns green.
Oh,
Are we gonna die? What does this mean?
make it red.
I'll make it green.
Make it green.
Red, we're fucked. I just pulled up 2 strands.
You're on camera.
Red just means that the whole system, like something is not connected. And
Yeah,
green is
nothing's gonna explode on
Alright,
us.
so
And then
here is your
green-
FRC driver station coded in LabVIEW. You have your drive thingy, and then here we can check for the Xbox controller. So here is our Xbox controller. You can see if I push one of the axes forward, you will see that it shows me how much you're pushing the axis on the actual FRC driver station. On the or also with this, as well as the buttons and everything, you can see it completely reacts. So, and that is hard coded into our system.
Is it supposed to move?
There is an increment of 0.02 acceleration speed.
Yay.
So,
Yay.
That's 12? No.
0.02 acceleration increment.
0.02. Is that
With
2?
the maximum speed capping at
Let's see that.
0.3, which is 30%. So now,
What a
now you
soul
won't see any.
story.
So
Onion recipe.
you won't see anything from here anymore because I am now changing to another one.
Onion recipe.
You figured it out?
Green, you're dead. Red.
Yeah, I figured out why I got. Oh yeah, I don't. Did I? Only Bernice was here and Ricky. Okay, anyways, we figured out the radio control.
Yippee.
We flashed the program onto the radio, so
Yay.
now we have our own Wi-Fi called FRC 10015. It's just a connection though, it's not an actual Wi-Fi, so you don't get Wi-Fi
Are
signal.
you planning on?
So you can't see anything up here, but I will bring this over.
Are you planning on?
Here
Guys, watch
we
this.
have the actual panel, which is hard-coded.
That'll be kind of
Now you'll have to learn each and every single code, which will take you
Yes.
around 1,000 hours to learn.
Bro, stop. Touch
So,
the stop.
Here, if I click enable, you will see that all of them are pure orange. Now this means that the system is active. There will be a light in the future, which I need to buy because now we are technically not doing proper FRC stuff without the light. But anyways, if you see proper orange, stay away from the table. Okay, now as you can see, I have the Xbox controller in my hand. If I push the joystick forward, it will move forward. If I push this joystick forward, it will turn. So now you can see when it's running, it will light green. So whatever motor is running, so you'll see sometimes it will light red,
Why is it red?
but that is fine. If it's blinking red, it's fine.
What does that mean?
It just means it's static running. So just running at minimum speed. So that means it's just not running correctly. The code is.
What's top speed?
Huh?
What's top speed?
What do you mean?
Top speed.
Top speed would be 100, but top speed right now is only 30%.
Ryan, can we take turns, each one operate for like a minute? Just feel it.
Don't run it yet. Hold on.
Bro.
Okay, run it.
Wow, so crazy, right? I'm not putting it down here. Guys, I'm so invested in this. I'm like so mesmerized by this new technology. Wow.
So pause it for a second. Don't push it forward. Okay, my hand's going. All right. So as you can see, from the thing, you can see that these are not at the same position. When running Swerve, you want these to be at the same position. That is why we need to buy camcoders, so I don't have to manually calibrate. Because right now I'm still manually doing that.
Run it.
How come Y is tighter than the
Run
other?
it.
They are the same tightness. So as you can see, it's not calibrated separately. Anyways, go ahead.
I am running it. This is not interesting to you?
No.
No. It doesn't sound really good. It sounds kind of bad.
It's actually very responsive and very smooth.
Wait, Ryan, how would you get it to like spin like both? Like get it to like rotate. If you had 4 wheels, but they had all these different directions.
What do you mean all this? They're all going the same direction.
If you had 4 wheels and there would be
So you
two
meant like making it
pairs,
spin on the spot.
like making it rotate on the spot.
Rotate on the spot would we have to code that, but that would just mean that
What? Oh.
that would just mean that that these two
Stopped it.
that basically from the image you saw, one would go this way and one would go this way. So then it would spin like this. So then that would be on spot you altering.
Oh, so it's.
So if this is on this corner and this is on this corner, one would go this way and one would go this way. This one would spin towards me, this one would spin that way.
How would you code that?
Something for you to figure
How
out.
would you control that?
How this. But
that-
we don't have that coded yet.
It's front.
Okay. Well, Bernice, you wanna
Okay,
try?
yeah, there you go. I'm done.
Bernice.
Yo, Bernice, you want to see this? It gets spiked.
I hate you.
So as you can see, instead of running it directly at the speed that she is pushing it at, we have a settle acceleration. So it's very settle, but it saves the motor from a lot of force, which means that we won't burn the motor out as quickly. I'm risking my life over here.
What's up, guys?
Once we get the actual robot set, that will be fun to drive.
How long you drive for?
Can we drive outside?
No.
You know how to basic.
The reason we can't drive outside is because these tires would wear out too quickly, and I'm not gonna
Too
put them on.
crunchy.
Alright, please.
I'm surprised these motors aren't hot, not hot at all. That's why we bought these instead of the Falcon.
Wow.
It's so
Yes.
much better.
How do you control this?
Stop torturing the
Go ahead.
You try it.
Stop torturing our mascot. Oh.
It's just up and down. Both of them are
Why
fine.
is the rat our mascot?
You can also, so like if you push a little bit forward, you limit the speed.
Bubbles.
So yeah.
Our mascot is literally real bubbles.
We're rats. Yeah, just the one on.
Maybe you are, but we're not.
Oh.
There's a difference between you and us.
I think it's not calibrated anymore.
You don't have to include it.
Yeah, you have to manually calibrate it. We don't have camcoders yet. Once we do, that's when the
Stop. First you steal the crimper and now you steal mine.
I see the what?
You stole the crimper.
Oh, the crimper.
Ah.
Where is the crimper?
Where'd the
guys?
crimper go?
Don't move.
Where'd the crimper go?
Go ahead.
Go to blind Kate. Kate's on a mission to go to college. He doesn't stop now. He just started, guys. Give him some time. Okay. I'm gonna get the tots off really quick.
Alright, Matthew. Go.
Hold on.
Hey,
Hold
no,
on.
never.
Don't
That's
run
not
it.
good. Seriously.
Me moving.
That's not good.
Pointing at lasers.
Oh yeah, Bernice.
Okay, go.
Fine. I suggest you don't trust me with any controllers.
Obviously, the first thing he does is go max speed.
Nah, whenever you guys play with this, I'm limiting the speed to 10%. And I'm keeping an emergency stop button on me at all times. I don't trust any of
Watch
you.
me go full speed and crash the robot, like I did with the other.
Yeah, I can do it because I'm risking my life here every single time. See how fast the gears are spinning? We're using an L2 ratio, gear ratio. So if my hand goes in there, I will lose a hand.
Oh yeah, Bernice, you just like hit your hair in that.
Oh my god.
While it's moving, see what happens.
And according to Ryan, the new video system has faster response time. So
Hey Ryan, will Top he'd beat Atraxis in a race?
In a race?
Yeah.
What do you mean in a race? Like in the competition?
No, just like a straight, just like a drag race.
It goes 40 kilometers an hour. These motors. But we're limited because it's an L2 gear ratio, so I would say pops around 20 kilometers an hour.
Wait, is this on?
Yeah.
Oh.
I like Alan to go first.
I was scratching it a little bit.
What are you two for?
Not coded yet. I'm waiting. Yes, everything. Well, depends. I'm still looking right now.
Have you
I need
seen
more
that one
references.
team where they control the robot using the back?
I need one more. It
you seen
depends
that?
for
Have you seen that?
next year.
Have you seen
Matthew, what
that?
did you do?
That one team where they control the robot with the guitar. So each chord is a different
Matthew, what
control.
are you doing?
No, don't keep enabling and disabling because it ramps up speed too fast. As soon as you enable and
You were on
disable
my
it,
field. You were
no acceleration.
able to see that. Where
Yeah, I'm not doing
once you
anything.
want to use this guitar as a control on the Xbox.
welcome to our first scenario. Click disable. Welcome to a fluke that we found.
What happened?
You put it on test mode.
Oh.
Don't touch the controls, please. Go ahead. See, just after a couple minutes of using it, we already lost 0.1 voltage.
Ooh, that's crazy.
Wow.
That's a lot. That's actually a lot.
Feels like the controls for a drone.
Yeah, Ryan speaks
Huh?
What are you doing?
Alright, stop.
This is a forced compensation.
Feels like
Because you have proven to not
it feels like the controls for a drone.
That's nothing, Terrence.
No.
That's pretty sick. Alright, now I'm gonna start assigning tasks. I'm still looking for one more person to help drive.
Yo, I can do it. I can.
Can I go to
I can.
Actually, no, you can't. Because I need you to be the captain. So
I
you have to go-
volunteer as tribute.
You're considerable.
No, you're not.
Aww.
You know the first thing she said? Watch me run at full speed and hit it into something.
No, she's not driving. I'm not. I'll be the driver, but I need someone to shoot
You can be a shooter.
and do everything else.
Ryan, anything else you want to
I
present?
confiscate.
Well, I mean, it's right now just jobs now at this point. That's it. Yeah.
Nothing
You can stop the video.
Okay.
It's just jobs I want to say now.
Don't ask me